I want to show you something. I know you've been asking yourself, you have seen most of the things like the embedded systems, the robotics and IoT. They seems to be so small, but they can achieve a little bit of surprising task. They can do a lot of tasks, and you are wondering what is behind this robotics and embedded systems, like the fridge. You get a fridge that has a display screen, can make a call, can do several things lately. So we are going to get to the behind the scenes of what is happening, and what is actually behind all those things happening. And the major thing when you want to learn about robotics, Internet of Things, or embedded systems, we will always talk about what we call the microprocessors and microcontrollers, and these are the brains behind all embedded systems and all robotics and Internet of Things. So an embedded system is a system built to do a specific task, like let's say environmental monitoring, like the pressure, the temperature, the climate, like something like a weather forecast. It's dealing with the weather. And then you get something like a fridge with the smart system in it, able to show you the temperature in the fridge. You can make call, can schedule events, can tell you a lot of things. Then we have the robots, like those that usually clean the rooms. Whenever the floor get dirty, they clean it. You find that they do a specific task. If it is a cleaning robot, it will do only the cleaning. Then we have microprocessors. Microprocessors are advanced, and they can multitask and do a lot of things at the same time. So an example of microprocessors are those processors in the laptop, the PCs, all those. You can run a bunch of softwares in them, and the softwares must not be the same software. So they are for different purposes. Unlike the microprocessors, they do specific tasks. They cannot do much though. In terms of the specs, microcontrollers are having a little bit of resources compared to microprocessors. You find that a microcontroller has all the RAM, the storage, that is the flash, and the processors in one package, that is integrated in one package. That is it. For example, we have this is Arduino Mega, and at the middle of it you can see this is called an integrated circuit IC, and this one is a programmable IC. We call it contains a processor called Atmega 2560. So that the processor, the flash memory, and the RAM is integrated in this chip, and this chip has what we call GPIO. GPIO are pins, output pins, that is input and output pins, to help you build systems that can communicate with the integrated circuit. This one here, IC, and the IC is able to process information and give you an output depending on the programs that are running in the IC. Remember, it's programmable. So the major thing is to know how to connect these to other, let's say, sensors. Sensors are devices that can measure the environmental parameters like pressure, temperature, humidity, light intensity, and so forth. So you must know how to connect these to the sensors so that they work as a unit. So the difficult part is knowing how to connect them without burning or damaging this, because they use different voltages, mostly 5 volts and 3.3. For this one, it uses 5 volts maximum, I think 2 amps, 5 volt 2 amps. So if you feed it a lot of voltage or a lot of current, you may end up damaging the chip inside this chip now. So these are the key role players in making embedded systems, Internet of Things, and what we call the Internet of Things. Okay, so an example is this, another one. We call this ESP. This is ESP 8266. So 8266, it has the Wi-Fi and Wi-Fi capabilities, and it has inbuilt RAM and memory, what we call the flash memory. For the ESP86, it has something like 20 kilobytes. It's very low, kilobytes of RAM. Then let's say not 16, something like 2 MB storage, that is the flash. So it cannot hold a lot of programs in it, so the resources are limited in a way. So this one is more powerful, a little bit powerful than this, because it has a lot of Wi-Fi capability, but in terms of output and input pins, this one is more powerful than this. So the only thing that this has more compared to this is this has Wi-Fi connection capability and some other, it's a little bit faster in terms of the frequency at which it operates compared to this. So the next thing is this one is also 8266, that is. So I have ESP32, is almost the same as this. ESP32 is more powerful. It has Bluetooth, Wi-Fi capabilities, and has more GPIO pins for input and output. Then we have this one, the lowest spec, that is the Arduino Uno. This one is below this. So this is the cheapest, followed by this. In terms of which one is powerful, this is more powerful than this. This is for entry level, and also this is for entry level. So but this one has more lesser resources than this, and some other like Raspberry Pi. I don't have my Raspberry Pi here now. Raspberry Pi is now a microprocessor. Microprocessors come in, they don't have integrated flash memory and RAM inside the same chip. They have different they have RAM in different separate, that is, then they are connected to communicate with the RAM and the storage, that is. So they are more powerful, they can multitask, they can run a lot of applications at the same time, but they are difficult to program and to program, that is. So for you to control, to use a Raspberry Pi, you must have a lot of knowledge on how to, it's a computer on its own. So it runs on OS, Raspberry Pi OS. So it comes with the OS installed, so it's just a computer. You can run a lot of things in it. You can browse and do things. Then you can run what we call RTOS for robotics, or operating system for robotics, and you can do sorts of things. The Raspberry Pi has, let's say, the maximum spec is 8 GB RAM, and I don't know, the let's say 8 GB RAM. Then we have something like I don't know, yes, 8 GB RAM. We have 4 GB RAM. Then we have 1 GB storage, that is. Then it has Wi-Fi connectivity, Bluetooth connectivity, Ethernet, and USB 3.0 connectivity. So it has a lot. Some has even the output, video output. They're using HDMI for audio output. So not audio, for the video and audio output. So Raspberry is more advanced than all these other microcontrollers. You remember that one is a microprocessor. So these are the brain behind all these Internet of Things devices and the embedded systems, the robots that you see. So if you want to learn more of this and how to control them, how to program them, join the Wajenzi Hub community so that you can learn more about robotics and Internet of Things and embedded systems and programming, that is. So see you next.